So we have a lot more things to cover with threads, but in order to provide a context for all the subsequent discussions, I'm first going to introduce a case study example and show you how it works. And then as we talk through the other details of the thread API and thread semantics and so on, we'll keep referring back to this case study so you can see sort of more tangibly how things work. So this case study you can download from this link, or you can basically clone it from this link. And it's a fun little program that will concurrently compute the greatest common divisor, which is, as you undoubtedly know from like third grade, it's the largest integer that divides two integers without having a remainder. And we're going to use this to show off a bunch of cool thread mechanisms. So here's the overall design of this app. I will kind of walk through this as we go through the other examples, and I'll show you quickly how it works. Again, you can get it here. So it's going to showcase a bunch of methods in the Java thread class, as well as alternative ways to give code to a Java thread to run. Because this is running as an Android app, we have a little helper class that we use for logging the lifecycle states of an Android activity. Not all that important for our discussion. It's more if you want to learn more about Android. We have a main activity class, and this is the way that Android presents the code to the user, or functionality to users through a main activity. Again, I won't go into too much detail about this. We'll talk about some of those details later. Basically, what this does is, as you'll see when I run the app in a minute, when you press the buttons on the app, this gets sent to methods in the main activity, which is where the wheels are set in motion to get things running. The interesting parts of this example are the GCD thread class, and you can see that GCD thread extends the thread class. So there's a thread class, and this extends it, it inherits, and it goes ahead and overrides the run hook method, which is a pure virtual method or an abstract method in the thread class. So we'll take a look at that in a second in more detail. And then there's also another implementation called GCD Runnable, and GCD Runnable is a class that implements the runnable interface and overrides its run hook method. And what you do there is you pass in the GCD Runnable instance as a parameter to the thread constructor, and then when you start the thread, it'll go ahead and run the computations that are defined here. So these do exactly the same thing. The functionality is identical, but the means by which it works is slightly different. And so what we're going to do now is we're going to kind of take a look over the next sets of lessons how these things work. But before I do that, I want to first show you how the program actually runs. So here is the user interface for the emulator that's running on my machine. And you can see, if you look carefully, it's got three buttons. It says Run Runnable, Run Thread, and Run Thread Runnable. And we'll look at all those different implementations later. But let me just show you what happens when we run. So we click Run Runnable. And what it does, it may be a little hard to see here because it's kind of small. But when you look at the video, you'll be able to tell what it's doing. What this does is it goes ahead and runs a loop many different times, going ahead and submitting essentially runnables to run these GCD computations concurrently. And this will tell you what thread the computation is taking place in, and it'll go ahead and show you the results periodically by polling the results and only printing them out every so often. You can also run the thread implementation. We'll look at those in a minute to see the differences. That does the same kind of thing. You can see it actually runs on a different thread. If you look carefully, this was thread 11. That's thread 12. And then we can run thread runnable, and I'll look at that later. And you can see that this one, unlike the other two, which ran in one thread, this runs in multiple threads. So we have multiple threads that are running. And once you see how the code works in more detail, the behavior of the app will make more sense.